To start off the second 9 weeks, we're going to focus more on trig, trigonometry. The first lesson will be trig ratios and right triangles. Lesson objectives. Find the values of trigonometric ratios for acute angles of right triangles. Keywords to know: hypotenuse, legs, side adjacent, side opposite, sine, cosine, and tangent. There are 3 components of a right triangle that we're going to need to know in order to solve the trig ratios. The 3 components are hypotenuse, which is the longest side and also opposite of the right angle. We have side opposite. It's side opposite because it's always opposite of the angle that we're trying to find the trig ratios for. In this case, angle theta. We have side adjacent, which is adjacent to the angle that we're looking for, which is angle theta. Three trig ratios are sine, which is opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Example 1, find the sine, cosine, and tan for angle A. All right, so angle A is right here, all right? So we're gonna label each side based off of angle A. All right, so side opposite of angle A is 4. So we're gonna label this one opposite. Of course, we know that the longest side, in this case, is 5, and it's also opposite of the right angle. So 5 would be hypotenuse. Which leaves side adjacent, which is 3. Now that we have all of our sides labeled, we find the sine, cosine, and tan. All right, so in the previous slide, we understood that the sine equals, the sine of A equals opposite over hypotenuse. Opposite is 4. Hypotenuse is 5. Cosine of A equals adjacent over hypotenuse. Adjacent is 3. Hypotenuse is 5. And then we have tangent. The tan of A equals opposite over adjacent. Opposite is 4. Adjacent is 3. Example 2, find the values of the sine, cosine, and tangent for angle A. So in example 2, we have, it's a little bit different, all right? In example 2, they give us 2 sides, but we're missing a side. We're missing the hypotenuse. So whenever we're missing the side of a right triangle, we use the Pythagorean theorem, which is a squared plus b squared equals c squared. right? So A and B represent the legs. C, or whichever variable is on the right side of the equal sign, represents the hypotenuse. So we set it up. These are interchangeable, so A squared plus 15 squared equals C squared. 8 squared is 64 plus 225 equals C squared. 64 plus 225 is 289 equals C squared. Whenever we have a variable squared, we take the square root. So side C equals 17. All right, so once we find side C, we label the sides. Since we're dealing with angle A, 8 is side opposite. All right, which makes 17 the longest side hypotenuse. Which leaves 15 as adjacent. So the sine of A equals opposite over hypotenuse, 8 over 17. Cosine of A equals adjacent over hypotenuse, 15 over 17. And the tangent equals opposite over adjacent, which is 8 over 15. Example 3. Find the values of sine, cosine, and tan for angle B. All right, so right here we have a right triangle, but in this case, we're missing the side, all right? We're missing one of the legs. We have the hypotenuse, we have a leg, and we're missing the leg. So once again, we use the Pythagorean theorem to find the missing side. All right, so 18 is a leg, say 18 is side B, missing side A. So A squared plus 18 squared equals 33 squared. A squared plus 18 squared is 324. $33 squared is 1,089. All right, from there we combine like terms. So one step equation, subtract 324, subtract 324. A squared equals $765. All right, so from this point, we find the square root of 765. All right, so we break this down, two numbers that we can multiply to get 765. 85 times 85 times 9. What's the square root of 9? 3. So A equals 3 times the square root of 85. So the next thing we do is identify the parts of this right triangle, all right? We're gonna identify the hypotenuse, we know which is the longest side, so that'll be 33. All right, since we're dealing with angle B, finding the sine, cosine, and tan for angle B, then side opposite of angle B is 18. Which leaves side adjacent just 3 square root of 85. So sine equals, put it right here, opposite over hypotenuse, 18 over 33. We always simplify, all right? 18 over 33 can be simplified. 3 can go into both of those. So 3 goes into 18 6 times. 3 goes into 33 11 times. The sine of B is 6 over 11. Cosine of B, adjacent over hypotenuse, 3 square root of 85 over 33. All right, the numbers outside of the radical can be simplified. So 3 goes into 3, 1. 3 goes into 33, 11. So the cosine is the square root of 85 over 11. Then we have tan. Tan of B is opposite over adjacent, all right? Opposite over adjacent. So 18 over 3 square root of 85. So it's a rule we use when we're dealing with radicals in the denominator. First thing we have to do is reduce that, all right? So 3 can go into 18, 3 can also go into itself. 3 goes into 18, 6. 3 goes into 3, 1. All right, so we're left with 6 over the square root of 85. We can't leave that radical in the denominator. So what we have to do is rationalize it by multiplying it by itself. That leaves 6 times the square root of 85 is 6 square root of 85. The square root of 85 times the square root of 85 is whatever's under the radical. So the square root of 85 times the square root of 85 is 85. The tan of B, 6 square root of 85 over 85.